May I help you?
Yeah, is this Candy Crush Company?
Yes.
So yeah, I'm interested in working with you guys because I saw your ad on the TV. So, may I come in?
Okay, come in.
Thank you.
Who's this?
Sir, he wants to join our company.
Please take a seat.
Sure.
So, what's your name?
Yeah, my name is Felipe Bonger,
What are your qualifications?
and I'm a flavorist actually. And I've been working in a company
But
for
like,
very long.
why do you want to work with us?
So it all started when Hey boss,
Yeah.
hey, check this out.
Oh my god, that's actually really good. If he keeps this up, he's gonna take my spot. Can't let this one slide.
Are you serious? You talking? This is good?
Yeah.
I'll pay you for this? That's
my-
not good, man.
That's my best product, man.
No. What is this?
What's wrong with it?
No, it's messed up, man.
Whoa, give me one more chance.
No, you don't get no chance for this. I don't right now. We don't need people like you. Take my glasses off
Give
right
me
now.
one more chance, man.
Take my glasses
Yo,
off.
man, come on.
Out.
Give me a chance.
I said out.
Give me a chance, man. That was my best product, yo. Whoa.
Hey, move. I said out. Get up. Get up. Get up. Get the hell out.
I don't intend on coming back anyways. And here we are today with the Candy Crush Company. And sir, what would you have to say about the progress of your company recently?
Our company is very low on money.
Hey, Usher.
Our
there's
sales-
something wrong.
Oh no! Jimmy! What? As you can see, our company's not doing so well, so we could really use some genius mind, someone that can help us.
And after that, I just decided to come and meet you guys.
Oh, yeah, okay, yeah. Yeah, so your story is really amazing, man. I think you can be a great help to us, you know? Let's grow. Let's do this.
Yeah. Okay, so guys, what do I have to work with?
Well, you see, when my dad died and left me with this company, he left me with all these acids and alcohols over here, and I have like no idea what to do with them.
Okay, so let me ask you guys this: like, do you guys even know what flavor is and how it works? Crickets. Alright, let me explain. So flavor is basically just a combination of taste, smell, and how the brain perceives it. Now the five tastes that a human can perceive are sweet, salty, bitter, sour, and umami. Now the most dominant factor in determining the taste is the nose. Now our nose can detect more than 10,000 different odors, and which is basically what we learn through experience. And yeah, so basically, what flavors do you guys want to work with?
Raspberry.
Banana.
Orange.
Okay.
Alright, so guys, in order to obtain these flavors, what we need to do is that we need to go through the process of esterification, which is basically when you combine acid and alcohol, and you get an ester out of it. So now let me explain. Okay guys, so first of all, how do artificial flavors work? So artificial flavors are chemicals that mimic natural flavors. Now there are many types of these chemicals, but the most effective ones are esters. Now the ester required to make a banana flavor is isoamyl acetate. The ester required for providing an orange flavor is octyl acetate, and to achieve the flavor of a raspberry, we must use isobutylformate. And now here's the structure for a banana flavor. So basically what we do is we add an alcohol and an acid. And what we get from that is ester and water. So when we add isoamyl alcohol and acetic acid while having sulfuric acid as the catalyst, we get isoamyl acetate and water. And that is where we got our banana flavor. And orange flavor is when we have an octanol and we add it with acetic acid, and what we get from it is octyl acetate and water. And octyl acetate is basically the ester that provides the flavor. Next is raspberry. So by taking formic acid and adding it with isobutanol, we get isobutylformate and water. So isobutylformate is the ester. Alright, so basically after you get the ester, what you need to do is that you need to add other chemicals in the right proportions, right? So that you get closer and closer and closer to the exact taste you want.
Wow, Felipe, you are a genius. I'm so glad we added you onto our team. But I personally think we should also use food coloring to make our food look way nicer.
Yeah, that's a good idea.
You know, I always wondered how food coloring works.
It's very simple actually, let me explain.
So what is food coloring? Food coloring is an additive for food or drinks that gives the food a desired color, for example green, red or orange. Why would we want to use food coloring, you ask? Well, it looks appealing first of all, and secondly it influences a perceived flavor in our candy. For example, if our candy has orange flavor, then making the candy look orange will help the brain perceive the flavor to be orange. Now how does food coloring even work? Well, it alters the absorption spectrum of the food. So say we have green food, and first of all it reflects green light and absorbs every other light. But if we put red food coloring into it, it will reflect red light and absorb every other light. Now what makes up food coloring? Well, food coloring can be made naturally or synthetically. Natural food coloring can come from vegetables or fruits. An example of natural food coloring would be carotenoids from carrots, which makes carrots look orange, and we could use this molecule to make our food look orange. Now for our purposes, we are going to be using synthetic food coloring. These molecules that you see here, brilliant blue and teratazina, these are food coloring molecules, and they're very complex, and they usually have double bonds and hydrocarbons and nitrogen groups within their structure. Now most food coloring compounds have this type of structure. This structure is called azo-compound structure, and we are in the food coloring we're going to be using have these type of structures.
Yeah, man, that's actually a really great idea. Yeah, it's a great idea. Yeah.
Jimmy! Do you have any idea what we're talking about?
Caramelization?
Huh, that's actually a good idea. What is that though?
So let me explain. Caramelization is the oxidation of sugars. This process is extensively used in cooking nowadays and results in a nutty and sweet flavor, and also brown color. The reaction involves the removal of water as steam and the breaking down of sugars. The caramelization reaction depends on the type of sugar. Caramelization temperatures of various sugars are given, like fructose caramelizes at 110 degrees, glucose, galactose and sucrose caramelize at 160 degrees, and maltose caramelizes at 180 degrees. The whole process is summarized in 3 steps. When heat is applied to the sugars, foam is produced. As the sugar compound sucrose decomposes to glucose and fructose. In step 2, now the individual sugars lose water and react with each other. This brings out the distinct flavors and scents. In the final step, the molecules get combined. Aldoses of monosaccharide gets transformed to ketoses, which is also a common sugar. A dehydration reaction is used within the sugars to bring out the flavor. The 3 main products of this process are a dehydration product, caramellin, the 2 polymers, caramelline and caramelline. Caramelization also happens when heat is applied to onions, carrots or other vegetables. This happens as carrots/onions have sugars present in them, which means caramelization is taking place. But onions, carrots or other vegetables also have amino acids, which means the Maillard reaction is also taking place.
I think I know what the Maillard reaction is. Let me explain.
Hey, I know what the Miller reaction is. Maybe we can use it to make candy. The Miller reaction is basically the reaction between amino acid in food with sugar after heating. The sugar that usually go through a Miller reaction are fructose, glucose, maltose, and lactose. In order for the reaction to be successful, we should cook the food at high temperatures. An example of a Miller reaction would be when Chinese food is marinated, then cooked at high temperatures. Here, the amino acid and sugars in the Chinese food will react. But how will they react? Basically, the sugar combined with the amino acid and will form a product called imine. This imine can become cyclic with the removal of water. A product called D-glucosylamine is formed. D-glucosylamine gives the food different color, odor, and taste.
Alright guys, so you know what? I think we got what we need to know, right? Alright, so let's get to work.
Okay guys, this is the moment of truth. Let's do it. Oh my god, we've done it!
It might seem crazy what I'm about to say. Sunshine, she's here, you can take a break.
Oh my god. Yo, I'm so happy we added you onto the team. Without you, we wouldn't have been successful.
Nah man, it's all you, bro. It's all you,
man, so glad.
It's all you, man.
Yo, wait, yo!
Who is that?
Hey, brother! Yo, boss!
Big boss.
What's this, first of all?
Hey, this guy's my partner. You got a problem with that?
Hey man, listen, I was thinking if you could come back and work with me again.
What do you mean again?
Company is going down. I need people like you.
I'll pay people like me when you kick me out?
Listen. Don't mind. Listen, I'll pay you good, man. You have a good car, a good house.
What do you mean good car, huh?
Look at that.
Car.
Forget that, yo. Forget that.
Nah, you forget that, man. I'm out of here, man. Let's go.
Hey,
Go, man.
hey, please.
It might seem